Alright, in this video, we are going to take a look at an integral that looks complicated, but we're going to take it step by step, and we'll discuss how to do it. Okay, so the first step is to realize that whenever you're integrating a fraction, you can't just integrate the top, integrate the bottom, and divide. I wish it were that easy, but it's not. What you're supposed to do is realize that whenever you are taking a difference between two expressions and you're dividing it by square root of x, that means that the first one is divided by square root of x and also the second one is divided by square root of x. Okay, so like both of them, not just one. And that means that the first term is going to become 2x divided by square root of x, and then minus, and then it'll be 5 divided by square root of x. So that's step number one. You don't just divide one, you divide both. Okay, now you have to use properties of exponents. Okay, let's look at the first one. Okay, so I've got 2. Let me just pull the 2 outside. And then x is the same as x to the power 1. Now, you might or might not remember that square root of x is actually x to the power 1/2. If you don't remember that, then you should. Okay, now, what happens on the bottom here is I'm again going to just, instead of square root of x, write x to the power 1/2. That's just something you have to remember. Okay, now, what do I do next? I need to write each of these terms as x to some power. Okay, now here I have two powers, 1 and 1/2. And there is a rule of exponents that says that you're supposed to just subtract them. Okay, 1 minus 1/2, that would be 1/2. Okay, now what about this other one? Well, this other one, it would be nice if x to the 1/2 was by itself, but it's on the bottom. So what do I do? Well, I have to take it and bring it to the top. When I bring it to the top, what happens to the power? Well, it becomes negative, okay? That's just the definition of negative powers. But what about the 5 that was there? Well, the 5 that was there is not going to go anywhere. It's still going to be 5, okay? So all you're doing is just bringing that x and making it negative 1/2. And all this work is just to go ahead and start integrating. I haven't done anything yet. I just rewrote it so it's ready for integration. Now I'm going to start integrating it. Okay, I've got 2 x to the power 1/2 minus 5 x to the power negative 1/2. Okay, how do I integrate that? Well, I just integrated using the power rule, and I remember that anytime I have a constant, I just keep it because it's a constant multiple. So I'll take 2, then I will have x to what power? Well, take 1/2, add 1. That's going to become 1/2 plus 1. That's what? 1/2 plus 2/2, so that's 3/2. And then you're dividing that by exactly the same thing that's in the power. So that's going to be 3/2 on the bottom. Okay, minus 5. Now let's take negative 1/2 and add 1 to that. Negative 1/2 plus 2/2, that's 1/2. So this will become x to the 1/2 divided by 1/2. Okay, so theoretically, because this is indefinite, I will still have to add plus c. Now, what do I do with this kind of like stacked thing where it's x to the power divided by 3/2? So usually we don't want to do that. What we do is instead of dividing by 3/2, we can multiply by its reciprocal, which is 2/3. Okay, and then we have x to the power 3/2 still, and then this one, instead of dividing by 1/2, we multiply it by 2. That'll make this a 10 x to the 1/2. Okay, so I'm pretty much ready to write the answer here. So this will be 4/3 x to the power 3/2 minus 10 x to the 1/2. Okay. Then what I need to do is actually evaluate the definite integral, because remember the original integral actually had limits, these 1 and 4, and I have to plug them in. Okay, so I will do that without a calculator. You are more than welcome to do it with a calculator if you have one, but I want to practice without. Okay, so what I will do is I'm going to draw that vertical line, and I'm going to put the bottom limit as 1 and the top limit as 4. And I always start with the top. I will have 4/3, then 4 to the power 3/2 minus 10, 4 to the power 1/2. Okay, so I evaluate that, and then I'm going to subtract the same thing, now plug in 1. Now, the good news about 1 is that 1 to any power is just 1. You're going to get 4/3 minus 10. Okay, so let's see. Well, Why do I want to do it without a calculator? Well, actually, because what is 4 to the power 3 halves? This is the same thing as taking square root of 4 or raising it to the power 1 half, which is just 2, and then cubing it, and that's 8. Okay, so that's 8. Then I get 4 to the 1 half. Well, that's the same thing as square root of 4, so that's 2. Okay, and then here let me distribute the minus, so I'll have negative 4/3 plus 10. Okay, so let's see if we can compute that. So 4 times 8, that's 32/3. And then I'm going to also have minus 4/3. And here have minus 20 plus 10, so that's minus 10. Again, you can just use a calculator here, but I'm kind of being stubborn and trying to do it without. Okay, so you got 28/3 minus 10. And then if we bring it to a common denominator, then 10, you can write it as 30 divided by 3. So my answer here is negative 2/3. All right, well, let's check that out.